Hey, it's Jacob. Welcome to this new video. So today I want to talk about the academic approaches that don't actually really work. So academic. And what is the problem with the academic approaches that are taught by the teachers and the PhD, right? The PhDs. The problem is they are not practitioners. They don't actually practice what you think they are practicing. So there's a problem with that. The practice, it's not that they are not doing things, they are doing things, but for them, it's more about papers and teaching. Right? This is just what they are doing. So for them, everything that's going to improve that part is interesting. But this is not actually building stuff, right? If you want to build your own products and create things, those types of approaches are not going to work, right? Because they are just doing something that is a little bit different from what we are doing. And they pretend like, or they actually think that this is the same thing because it resembles it looks like it, right? But in the real world, it's a little bit different. And so what is the main problem with that? Let's clean that up. And there is a problem, right? And the problem is the problems. So let me explain. It's about like the problems that they are identifying as problems because they think that it looks like they are problems, right? Because they think they have an idea of what building a product looks like, and their idea of building that product involves a few theoretical problems that they think are going to be difficult to solve. And so they're working on those problems that they think that is going to help people, right? But the idea of the problems is not the actual problems. So they have the wrong problems. Because by the way, like I'm not even saying that what they're doing is wrong. Like they don't have the right solutions. They have the right solution. So right solution, but to the wrong problems. So basically, when you follow those types of academic approaches, you're going to learn the correct solutions for the wrong problems. When I say wrong problems, it's not necessarily that they're bad, or it's just that they are not really relevant to what people are actually doing in the real world. Like, and so okay, let me give you an example. Let me remove all that. And what are the problem? So those problems, we need to understand one thing, and this is the main point of the video. It's those problems are necessarily not reflective of the real world problems. And the point is, the reason why they are not reflective of the real world problems is because precisely they are talking about it. Like, again, remember that their thing is about teaching to other people, right? Part of their job is about that. And so they're going to talk about known problems. And what is the problem with known problems here? The known part, there is an issue with that because if people are talking about it, if it is known, then there is going to be probably an existing solution, right? The problem is the existing solution. Why is it a problem to have an existing solution to a problem? Because if you are going to bring value to someone, and if someone is going to pay for it, you can't have an existing solution to the problem. You're not going to make money from it. because precisely because it's existing already, right? So I'm going to give you an example of that. So most of the academic approach are talking about the gradient descent, right? Gradient descent. So just to make it super easy to understand what it is about, it's when you have like a neural network. A neural network is just something that learns from examples. Well, you need tons of examples, right? Like let's say here you have the examples. This is the examples, right? And you feed it to the neural network. And then there is an algorithm that is the gradient descent that is going to adjust the neural network here. So it's going to adjust it. We call it training. It's going to train the neural network in order for the neural network to become good, right? So you need that algorithm. So that would make sense for an academic to say, well, this part is important if you're going to learn about neural networks, right? You need to learn about gradient descent, right? Now, what's the problem with that? The problem is gradient descent, you need to know about derivatives of like derivatives of it's a little bit complicated, but like basically of the error of that the neural network is making. You need to calculate the derivatives of that in order to know in which way you need to adjust the parameters of the neural network. It doesn't really matter. The point is those derivatives and that algorithm, like you need some kind of mathematical background, right? So the problem here is the background that you need in math. It's pretty heavy, by the way. I mean, background. Sorry, sometimes it's difficult to write when I talk. So mathematical background, so math. And the problem is if you don't have that background here, it's going to be a little bit difficult to actually understand what that means, right? And some people are going to say, well, I can explain to you and whatever, but like it's going to take time for you to understand. Maybe not for them to explain it to you, but like, yeah, you need a little bit of mathematical background. And you need to know like what gradient descent, what type of algorithm that is, the fact that it can optimize for things and that it has been applied to neural network, but it's actually a very general thing, right? So there is more to it is what I mean. So what's the point of what I'm trying to say here? The point is you do not have to learn any of that. And why? Because there are people that have implemented that algorithm here. For example, you have like the PyTorch library in Python. And they're going to give you the algorithm like right off the bat. You don't have to learn how it works. In fact, like it's difficult to actually like look at it. Like you don't have access to it easily. Like no one is looking at how it actually works and is going to like to modify it. Everybody that is using those type of algorithms, they are just using it right as is, right? So the point here is to learn how. So here is the point. Learn how to use it well, right? Because it's a trade-off. If you are spending time learning how that works here, you're gonna not use your time learning how to use it well. So even if you have that mathematical background and even if you can like learn how it works just because you want to learn it, that's great, but understand that you're wasting your time. I mean, you're not using that time to learn how to use it well. So that's the main point, right? you don't need to know how it works under the hood. And for another reason also, like if let's say you really want to learn because you want to modify it or make your own, right? Well, here's the thing. The people that worked on that, on this thing, like the gradient descent algorithm, well, they are really, really good at what they are doing. If you do it yourself, you're probably not going to do it as well as they did it, because like there is like optimizations that they've done based on like the CPU of the computer, because it's not good enough to just train a neural network. I mean, once you've done it, it's good, but after that, like you want to go further, you want to optimize the way to train the neural network. So make the gradient descent, like basically allocate some resources based on like the CPU you are using or the GPU and all that stuff, right? And it's like, do you really want to learn how to do that in order to try to get as good as they did? Because you're not going to make it better. You're just going to get as good as what they did it, right? So it's like all that is completely useless unless you wanna do it just for fun, right? So the entire point is stop trying to learn these types of stuff. You know, those theoretical stuff, the math, the derivatives, like the algorithms, and instead learn how to use the existing solutions. So that's it for this video, and see you in the next one.